Dr. Mich Kaku is a professor of theoretical physics at City University of New York's new book's called Physics of the Future, How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100. Please welcome to the program, Mich Kaku. Good morning, Professor Kaku. How are you?
Morning. Hi. Glad to see you.
I see you. My wife saw you on either Bill Maher or Colbert.
I've been on both shows.
Okay. She said, man, and on Fox a lot too, I guess.
That's right.
She said, man, what an interesting guy. You ought to have him on. I said, he might as well be speaking Russian because I have no idea what he's talking about. So, first of all, you're a quantum physicist?
That's right.
What is that?
Well, quantum physicists look at the question of where did the universe come from? How will it evolve? How will it die? And we try to find the theory of everything, an equation 1 inch long that will allow us to, quote, read the mind of God. Right. An equation that summarizes all physical laws in the universe. That's what I do for a living. That's my day job.
You think there is a God?
Well, you know, Einstein was asked that question, and he said there are really two kinds of gods. One God is the personal God, the God that you pray to, the God that parts the waters, the God that smites your enemies in the Philistines. But then there's the God of Spinoza, the God of harmony, beauty, elegance, that the universe is so gorgeous, it didn't have to be that way. And so he believed in the God of order.
Yeah, but I didn't ask him. I asked you what you thought.
I lean toward Einstein's conception that the universe is so gorgeous. You know, you can put all the laws of physics on a sheet of paper, all the laws of physics, 2,000 years of investigation into the nature of matter, and you can fit it on a sheet of paper. And it didn't have to be that way. The universe could have been chaotic, random, but here it is. Gorgeous, beautiful, elegant.
Seems to work okay, right?
Yeah, that's right, and it works.
Yeah. So Einstein theory of relativity, that differs from your theory. To explain that.
Well, there are two great theories.
Okay.
Mother Nature has a left hand and a right hand. The left hand is relativity, the theory of the big, black holes, big bangs, quasars. And then you have the theory of the small, the quantum theory, which makes possible laser beams and iPods, iPads, lasers. All that stuff is made possible by the quantum theory. The two theories don't talk to each other. The theory of the big and the theory of the small. The theory of everything unites these two theories into a comprehensive framework, and we think we have it. Einstein missed it. For 30 years, he was chasing after the theory of everything. We think we have it. It's called string theory. Right. And we believe that music is the language of nature, that all of us are nothing but vibrations, musical melodies on tiny little vibrating strings. And we're going to try to prove it outside Geneva, Switzerland, with the largest machine of science ever built, 17 miles in circumference, the Large Hadron Collider. We're going to try to recreate a tiny bit of Genesis to prove the correctness of these kinds of theories.
So how will the experiment, how will that manifest itself? I mean, what will happen?
Well, we're going to slam two beams of protons together at enormous temperatures. If you saw the movie Angels and Demons with Tom Hanks, they actually filmed at the Large Hadron Collider. And we're going to slam two beams of protons together to create energies not seen since creation itself. And we hope to create new generations of particles called sparticles. Sparticles are nothing but higher vibrations, higher octaves of vibrating strings. We're the lowest octave. Everything you see around you, protons and neutrons, represent the lowest octave of tiny little vibrating rubber bands. But there are other octaves, and we hope to generate them with the Large Hadron Collider.
So you're one of the founders of the string theory, right?
That's right. I'm the co-founder of string field theory, right?
And that is that.
It's an attempt to summarize all of string theory into an equation 1 inch long.
Yeah.
That's my equation, by the way.
It is?
Yeah.
Okay. What, going back to when you grew up and so on, from San Francisco, was it? Or?
Yeah, I grew outside San Francisco and Palo Alto, which is now Silicon Valley.
Beautiful area. So.
Yeah.
So what got you to thinking that you wanted to spend your life thinking about this stuff?
Well, I heard that Einstein had died when I was a child, and I heard that he couldn't finish his greatest work. And so I said to myself, well, what could be so hard? I mean, it's a homework problem, right? Why didn't he ask his mother? And then I realized it was the theory of everything that he tried to create. And then when I was in high school, I decided to build an atom smasher. I went to my mom one day, and I said, Mom, can I have permission to build an atom smasher in the garage? And she said, sure, why not? And don't forget to take out the garbage. So I built a 6 kilowatt, 2.3 million electron volt Betatron accelerator in the garage. Every time I turned it in, I blew out every single fuse in the house. And my poor mother, she must have said to herself, why couldn't I have a son who plays basketball? Maybe if I buy him a baseball. And for God's sake, why can't he find a nice Japanese girlfriend?
So the other kids are building soapbox. They're getting a soapbox derby, and you're in the garage building an atom smasher, right?
That's right. 6 kilowatts, 22 miles of copper wire, 400 pounds of transformer steel. It was so powerful, the magnets would rip the fillings out of your teeth if you got too close to my machine.
So you're like a child prodigy, right?
No, I just had a fascination with physics. Physics is the language of the universe. I can't understand why people are not fascinated by physics.
Well, it is fascinating. A dope like me can be fascinated. It doesn't even. I'm not being self-effacing either. I mean, but it is fascinating.
Yeah, we're talking about the fact that we physicists created laser beams, transistors, X-ray machines, television, radio. Most of what you see around you was invented by a physicist.
But I'm sort of interested. I mean, fascinated. So when did you realize that you were a lot smarter than the other kids were just little dopes thinking about nothing, fighting over whatever, and you were thinking about this stuff?
I begin to I'm an educator now as well as doing research, and I begin to realize that we're all born scientists, all of us. All of us wonder where the stars came from, where we came from, and then we want to know about these things until we hit high school. And then it's crushed out of us. Peer pressure kicks in, hormones kick in. You have to memorize all the parts of a flower and all the boring things that are totally irrelevant. And then it's crushed out of us. No. And so now President Obama talks about the Sputnik moment. We have to recreate a Sputnik moment for high school kids so they don't drop out like flies in high school.
We're talking with Dr. Mich Kaku. His book, which is very accessible, by the way. I mean, I could read it. So I'm not assuming that you're on my intellectual level. You're probably way above that, but it is accessible.
Probably.
Physics of the future. Yeah, there's no probably. That's an absolute, isn't it?
No question.
So, so what are some of the things like time travel?
Well, let me just give you a taste of some of the hundreds of predictions I make in the book, including time travel.
Well, before we get to that, this whack job predicting the end of the world and the rapture and all that. Do you buy into that?
No, I think we're going to be around on the 22nd. Don't sell the store. Don't get divorced. Don't quit your day job because you may live to see the 22nd.
Yeah. Now you were going to say?
Yeah, I make hundreds of predictions in the book based on interviews I've done with 300 scientists. For example, the Internet. People always want to know the future of the Internet. It's going to be in our contact lens in 10 to 15 years. So you'll blink and you'll get online. Your contact lens will recognize people's faces and print out their biography right next to the image. So at cocktail parties, you'll always know exactly who to suck up to at any cocktail party. And who will buy these contact lenses? But college students studying for final examinations. They will blink and they will see all the answers to the final examination in their contact lens. Very popular.
But how about time travel?
Time travel we think is possible. Stephen Hawking has actually gone back and forth several times on this question. But you need an enormous amount of energy to drive a hole through space and time. Time is a river, we think. It speeds up and it slows down. But we also think now that time can have whirlpools. And if you get caught up in one of the whirlpools of time, you can actually go back and meet your parents before you're born. And if your teenage mother falls in love with you, you're in deep doo-doo.
Let's not get crazy with us here now, Doc. We time travel certain things now, right? I mean,
our astronauts actually go into the future a little bit. It turns out that our astronauts are time travelers. Time beats at different rates in outer space. The moon, time beats faster on the moon than it does on the Earth. We can measure that. Time beats slower on Jupiter than it does on the Earth. And our GPS systems, your cell phone, has to take this into account when it communicates with satellites. Otherwise, the GPS wouldn't work.
Stephen Hawking, you know what's going on or no?
Yeah, Stephen Hawking made headlines a few months ago, and again last week, when he said that God is unnecessary. There's no heaven, there's no hell. Right. In his book, he said that string theory, which is what I do for a living, is it. This is the final theory. Okay. This is the theory of everything. Therefore, he said, we don't need God. We have a theory that takes us before the Big Bang, he said. We have a multiverse theory. Our universe is a soap bubble, but there are other soap bubbles out there, other universes, and they bump into each other, and that's the Big Bang. So we don't need God, he said. Now, I think that's going too far because, I work on the theory too. And it seems to me that it doesn't answer the question, well, where did these bubbles come from? Where did string theory come from? Where did the multiverse come from? So I think we still have to, appeal to, quote, higher authorities to answer the question, well, where did all this come from? Where did the mathematics come from?
Not to mention the fundamentalists and the Baptists. So we have to appeal to them too. The parallel universes, that's a real deal?
Yeah, we physicists study parallel universes. Sure. In fact, we're creating what are called quantum computers, which actually compute in different parallel universes. And it raises a question, and that is Elvis Presley still alive in another universe? And it cannot be ruled out. It can't be ruled out that the king is alive in another universe.
How do we get there?
Well, that's the problem. You need enormous amounts of energy, far beyond anything that we can muster, to go between universes. These are called wormholes.
No.
Think of the Looking Glass of Alice. The Looking Glass of Alice is a typical wormhole that connects Wonderland with the countryside of Oxford. And you can also use wormholes as time machines to go backwards in time. But the energy necessary to open up a gateway in time is for our great-great-great-great-great-grandkids. So one day, if somebody knocks on your door and claims to be your great-great-great-great-great-granddaughter, don't slam the door.
Yeah. So what do you teach now?
I teach physics at the City University of New York.
And stuff like this, right?
Yeah, I usually teach in the graduate program. I usually teach graduate students. However, this semester I'm teaching astronomy to freshmen, and it's quite a challenge.
What do you mean, for them or you?
Both.
Well, you're a fascinating guest, God.
Well, thank you very much.
Thanks, friend. My wife was right, so. But then she always says, thank you very much for coming in. I appreciate it.
Okay,
Mich Kaku, his book's called Physics of the Future. It's 12 minutes now until the hour.